Number 3 says use the graph of f of x equals 4 to the x power to obtain the graph of g of x equals 4 to the x minus 4 power. Okay, this is what I was talking about earlier as far as your transformations. Okay, I'm going to first graph 4 to the x, and I've just chosen these values for x. So we could pretty much do these in our head. If I plug in negative 2 in the place of x, 4 to the negative 2 power would be 1/16. If I plug in negative 1, it would be the reciprocal, so it would be 1/4. And then 4 to the 0 is 1. 4 to the first power would be 4, and then 4 to the second power would be 16. Okay, so I'm going to graph that function first. So I have negative 2, 1/16, negative 1, 1/4, 0, 1, 1/4, and then 2/16 would not fit on my graph. Okay, so we know we have the shape again of the exponential function, a little steeper than the previous one that we graphed. Okay, so if I wanted to graph g of x, look at your equation and see what has happened. What type of transformation do you have? Okay, because this constant is being subtracted from the variable directly, we know that the graph is going to be shifted to the right 4 units. Okay, same way that it worked in the previous chapters. So I could just take the points that I have here and shift all of them over to 4 units to the right. So I know if I have 0, 1, I'm going to have a point here at 4, 1. And if I had a point 1, 4, then I know that point is then going to be 5, 4. Okay, I can do the same thing with the points I have here and just shift all of those over to the right 4. So a lot of your graphs in your homeworks may be transformations. Okay, so just remember the same rules apply as the ones we've talked about in the previous chapter. You know, if this had been 4 to the x, then minus 4 from the entire function, let's say we had h of x equals 4x and then minus 4 from the entire function, this would be a vertical shift to 4 units down. Okay, so same rules that we talked about before with transformations. Okay, you can see a few word problems here with exponential functions, especially pertaining to interest formulas that we'll talk about later. But I wanted to give you at least one here that you should see kind of similar to this on the homework. It says the rabbit population in a forest area grows at a rate of 7% monthly. If there are 180 rabbits in September, find how many rabbits, rounded to the nearest whole number, should be expected by the next September. And it gives you the equation that you should use. Okay, so it has y equals 180 times 2.7 raised to the 0.07 times t. Okay, the 0.07 was our rate, and 180 was the amount of rabbits that we had in September. Okay, if we want to know how many we have by the next September, how many months have passed, okay, between those? Well, 1 year or 12 months. So in the place of t, I'm going to substitute a 12. And so really this becomes a matter of using your calculator. Okay, this is just a scientific calculator that I have here, Texas Instruments, which is sufficient for you to use on your final exam and your tests and things like that. I'm just going to show you on my calculator. On yours it may be different. You may have to play with yours a little while to figure out how to get the same answers that I'm getting here. So we know that only the 2.7 is being raised to these powers. Okay, so be careful, you don't want to multiply these first. You want to go ahead and raise this to your power. So what I did was type in 2.7. The exponent key on my calculator is this y to the x. On some calculators it's going to look like that. Or it would be x to the y sometimes. or some of them actually have just the arrow, the little caret key pointing up. That's your exponent key also. So if I wanted to raise 2.7, hit my exponent key, and then open parentheses, because I want to multiply 0.07 times 12, close the parentheses, and then hit enter. So that gives me 2.303, and then now that's the equivalent of this part of my expression. I multiply now times 180, and so that gives me y equals 414. It says 0.58, so we want to round to the nearest whole number. That would round up to 514. Okay, make sure you pay attention to your directions on the homework as far as how many decimal places that they want you to keep on these. Okay, on part 2 it says functions with base e. We have something in mathematics called the natural base e, and what I've done here, first I'm just going to show you, kind of cover up this part, and show you the expression 1 plus 1 over n, all in parentheses, to the n power. Okay, what I did is I plugged in different values for n. Notice I started at 1 and I went up to 1 million. Okay, so a pretty significant jump there. But I'm plugging those numbers everywhere I have an n in this expression. Okay, I want you to take a look at the values that I got here once I plug those in. Okay, first we started out with 2, 2.25, 2.4, 2.5, 2.7, but as I went from 1,000 to 1 million, which is pretty significant, I still kept the first few decimal places here. Okay, so by looking at this chart, let's fill in the blank to the statement I have here. As n approaches infinity, 1 plus 1 over n, quantity raised to the n power, approaches what number? Okay, as my n value gets larger, what is the value here approaching? Okay, we say that it's approximately 2.72, and that's rounded off, and we say that that is the value of e, the natural base e. So we have the function f of x equals e to the x is called our natural exponential function. Okay, natural exponential function. On the calculator, if you were to go to the calculator, you need to find your e key, which I have here. If I wanted to raise e to the first power, which would give me the value of e, I would have to actually type in a 1 and then hit on my calculator second and my e function. It gives me the 2.71828, so on. Okay, so again, you'll have to look at your calculator to determine how to type these in. You'll have some problems like number 5 on the homework. Approximate the number using a calculator. It says round to 3 decimal places. It's e to the 2.1 power. So on my calculator, I would have to type in 2.1 first and then activate my e key. Okay, so this is approximately 8.166. Okay, it said to keep 3 decimal places on these.